Hi class, welcome to our discussion of streams and rivers. In this set of segments we're going to talk about how streams evolve and change, the various features and parts of streams, and then how we can recognize some of the processes that are occurring in streams. We're going to link this beginning with the hydrologic, or link it to the hydrologic cycle first, so that's what we'll talk about right now. And we'll move on to talk about drainage divide, stream maturity, processes of erosion, within streams, and then a broad concept of sort of equilibrium or balance between erosion and and deposition in streams and what that looks like. In general, the hydrologic cycle involves two basic concepts. It involves a series of reservoirs, which I've listed most of them here, that hold water, and then it involves processes that transport water between these reservoirs. By and large, we assume that the abundance of water on the Earth's surface is constant or fixed, so we're not really losing that much water from the Earth, maybe a little bit from the atmosphere out into space. And so that when we make calculations within hydrologic systems, rivers, streams, lakes, and so on, we should be able to account for all the water that's there. Now, this is pretty difficult to do because there's a lot of variables, including biologic variables that we usually have to use approximations for. But the idea is that if you lose material from the ocean and it goes up into the atmosphere, it's going to end up on land somewhere or back in the ocean. And so we'll get rivers, lakes, we'll get some locked in ice. Now, every year ice will melt, so depending on climate, we may see some variation in ice, and more water may be locked in the ice than the previous year. And then moving through as part of groundwater. Basic processes involve energy from the sun to cause evaporation or precipitation, and then gravity to drive runoff and runoff in the form of rivers and streams, and then subsurface flow in the groundwater. And so any losses must equal gains in our little set of reservoirs and systems here to create a kind of balance. So every year the ocean loses 434 cubic feet from evaporation, right? Now, some of that material is going to come straight back into the ocean, but we need to get it all back into the ocean. This is just an approximation. So some of it's going to come straight back through the process of precipitation. Ocean water evaporates, and you have a rainstorm or a storm over an ocean, which just dumps that water back in. The rest of it, though, has to come in from melting ice, whether that's sea ice or whether that's glacial ice from continents or ice sheets. It has to come in from surface runoff, okay, and it has to come in from groundwater flow. So each of these is going to have its own little value in terms of cubic feet per year. And so here's an image of this system, right? We see gravity is one of those key factors. Okay, we have higher elevations, so we have potential energy up here, and then we have solar radiation as another source of energy. Evaporation out puts water into the atmosphere and brings it onto land, where we're going to see it deposited through precipitation. We may also get condensation and precipitation out here in the oceans, okay, to bring the water back in. Some of that water may be locked up in the ice depending on regional climate and weather patterns, and then a lot of it's going to move down along over the surface, okay, and back into the ocean. What is interesting, and we talked about this in maybe the first chapter, is that the biggest source, the biggest source of water in our system for fresh water is groundwater at 0.63%. So it's less than 1% of all the water, but it's actually quite a bit more in the subsurface down here. Okay? Than we have on the surface and in many lakes, even the Great Lakes. So a lot of water is actually moving from high elevations to low elevations down back toward the ocean. And you get an area in here. This area here is salty groundwater that's interacting with ocean water to some degree and recharging the system. Okay, so the primary drivers for the system would be thermal energy, heat from the sun, okay, and then gravity and flow from high elevations to low elevations.